First of all, we're going to take out the common factor to this one. So when we take out the common factor, I hope you can hear me, right? Hello, am I clear? We take out the common factor from our first row. So when we take out the common factor, we get this. Remember, those other ones, they are going to be the same. Are we still together? Hello?
Yes.
Okay. Now, when we take out the common factor, we're going to get that our matrix is 3 into 3 divided by 1 is 1, 6 divided by 3 is 2, 9 divided by 3, 3 divided by 3. You get this. So the other matrix or the other elements that are inside the matrix, you write it the way it is. So let me try to turn off my video so that you may not see me. Yeah, I think this will be better. So now, when we proceed, we find that now we must have how many zeros? 1, 2, 3, 4, 5, 6. If we have 6 zeros and we find that this is our upper triangular matrix, we are going to find the determinant by multiplying the diagonal element. Then in order for us to get 0 to this second row, first column, it means that we are going to say row 2 is going to be given by row 2 plus row 1, where you will see that we are going to have something like this. We're going to have something like this. When we say row 2 plus row 1 to give a row 1, you are going to rewrite it the way it is, and row 3 to write it the way it is, and row 4 to write it the way it is. So now, where we change things, I use the different color. Then this one is 0241. So try to verify using your calculator. Hello? Try to verify using your calculator.
Sipho.
Nah.
Meeting.
The main reason is what?
Let me check. Wait. I'm in the check. Kama ira unable to join the meeting. Mangwa iri meeting or incorrect.
Okay, let me resolve that issue before we proceed. Let me check. Okay. Let me see. Look at me.
Look at 20.
Is question what?
Tell me.
Question what? Oh,
Plus
for
60.
this one, this is plus 60.
Yo.
You're right negative. No, it's plus. It's plus.
Aye.
It's plus 60. The plus one.
But wasn't it okay? Already plus the other is of course one.
No, Chico Bonara, none could be solved available. But whenever Korea could go to join a meeting, problem the Goshim's a laptop or in a other days only at the design. Ndivanga but whenever borrow join a meeting.
Do whenever
No. Problem if you review no kono join isa ani kere bang mo borrow join na then different self faces. Can be with meeting when you require password.
yeah.
So I don't know what to do now.
Tunda kujisamo jenanga PC ya hana sunanda jenanga for.
PC Juana. Ora una mtu jenonga PC meeting hapa. I don't know, but those people, this a person. The meeting is being recorded, so the people will go through the recording. Because for now I'm still busy and I'm just sacrificing for you guys. So now let's proceed. So far, do you understand? Do you understand why we said row 2 is going to be given by row 2 plus row 1? So that we may have 0 here. Are we still together?
Yes.
Okay. Now, so it means we are going to have this thing. If you say row 2 is given by row 2 plus row 1, we are going to have those numbers. So to check or to obtain, now we move to the third row, so that where they say 1, we must have 0. So what are we going to do? We are going to say row 3 minus row 1. Are we together? So now it means we are going to have something like this. If we say row 3 is given by row 3 minus row 1, it means here we're going to say 1 minus 1, and we got 0, which is this. We're going to say 3 minus 2, we have 1. We're going to say 2 minus 3, and we got negative 1, and you proceed the way it is. So now, do you see those these matrices? So on these matrices, we are only left. Remember, we first deal with the first row. On first row, under the one for first row and first column, we must see zeros. Then we proceed to the second column. In order for us to have 0 here, we are going to say row 4 is given by row 4 plus row 1. We don't focus on other numbers, but we focus on this one that we have to change it to be 0. So this one, row 4 plus row 1, here it means we get 0. Then we're going to have something like this. We're going to have those numbers. You guys will press your calculator to verify whether what we wrote is it correct or not. Are we still together? Are we still together?
Yes.
Am I too fast? Mkundiwe, show all the steps. So guys, are we still together?
Hello.
Yes.
Huh?
Yes. Ma, some common factor fail.
Orang?
Tell ke kushisa more some common factor fail.
Oh, you understand where we take out the common factor. So we must have this kind of thing here. This is what we have to obtain. We must have those zeros under. So if we got 0, this 0, make this 0 and make this 0 and make this 1, 0, 0, 0. So when we have zeros, it means we have fulfilled what we are trying to solve. So now, in order for this one, after taking out the common factor, we're going to have this guy. So after having that guy, so which row are we going to add or subtract with the row 2? So that, because remember, this -1 here is at row 2. So which row are we going to add with or subtract with, so that we may have 0 at our row 2? It's a row 1. So row 2, we're going to reduce. Row 2 is given by row 2 plus row 1. So we start by the row that we want to change it to be 0. So row 2 is given by row 2 plus row 1. So when we say row 2 plus row 1, -1 plus 1 is 0. So that's why here you see we've got 0. Do you understand now? So we do the same thing to other. You apply the same approach to those other numbers. Then you will see, you will get this. Are we fine? So we are done with this one. We want to change this to be 0. How do we make this to be 0? We say row 3 is given by row 3 minus row 1. Why here we add? Because this is already negative. So negative plus positive, it gives us 0 if the numbers are the same. Now, it means if you apply this row echelon form, you are going to obtain something like this. So when you are changing row 3, you focus on row 3 only. You only focus on row 3 only. Then those other numbers, those other rows, you are going to rewrite it the way it is. So now, let's see. Why did we say row 4 is given by row 4 plus row 1? So that here we may have 0. So that here we may have 0. So now, wait. So that here we may have 0. So now, after having 0, you test other numbers. -2 plus 3. This is what you have. It's -2 plus 2, sorry. -2 plus 2. This is 0. Then you continue the way it is. -2 plus 3, you get 1. So you proceed. But now we are done with row 1. So we're going to we're going to column number 2, because we moved to column number 2. We're done with column 1 now. We move to column 2. So in column 2, here we must have 1. But there's a 1 under the second row, second column. So we are going to swap those rows. We are going to swap row 1 we are going to swap row 2 and row here I did a mistake. This is a row 2 is being swapped with row 3. If you can check, may you please change this one and write row 3 is row 2 swap with row 3. This one, it must be row 2. It must be row 3, row 2 swap with row 3. Did you change that? Guys, did you change that?
Yes.
Yes.
Okay, thank you very much. So now, can we proceed? After swapping, you are going to have this thing. So now, we want to make this one to be 0 now. What do? We're going to say row 3 is given by row 3 minus 2 times row 2. So that this one, when we multiply with the 2, it gives us 2. Therefore, so that's here we must have 0. So it means if you apply this row echelon form, you're going to have this on your row 3. On row 3, we're going to have this, and other rows will be the same. Did you see that? Hello? Did you see that? So now,
Yes.
since we are, if we go back here, if you can check, we have 0, 1, 2, 3, 4, 5. We have got 5 zeros. What are we left with? With only 1 0. But it means we are going to move to the third column, and where there's a 6, we must make sure that there's a 1. So meaning that what are we going to do? Since there's a 1 under 6, it means we swap. If you see the answer that you want is at the second row, it means you swap those rows. So we're going to swap row 3 and row 4. So when we swap row 3 and row 4, it means we are going to have what? We are going to have what? Unlimited voices. So when we swap those two, it means you are going to have something like this. So now we must make sure that where there's a 6 now, we have 0. So what do? We say we apply this row echelon form. Row 4 is given by row 4 minus 6 row 3. Why 6 row 3? Because those two numbers won't change. You must first check those numbers. So now, row 4 is 6 minus 6 row 3, you get 0. So that's why here those rows are we are going to have this. So you will test to other rows. So to find, you must take note for this. To find the determinant of an upper triangular matrix, we multiply the main diagonals matrix. So what is our main diagonal here? Let me highlight it for you so that you may see. This is our main diagonal. Why are we multiplying our main diagonal. Remember this, there's a 3 outside. 3 is always outside our determinant, which is going to do what? To multiply. So now, check here. This is your zeros under the upper triangle. Huh? So when you obtain the zeros, you stop. Now you multiply the determinant. You multiply. So that's why here we wrote the determinant of matrix D is going to be 3. Why 3? 3 is outside, is the one that we take it as a common factor. So is 3 multiplied by the main diagonal. Main diagonal, we've got 1, 1, 1, and minus 7, which will give us a minus 21. Any question before we proceed? Nah.
Jambora arero kofero kweta ro reduction. Afanoni jambora utebwa una 1 coming the diagonal unotebwa na 1 zitara na 0 ngapasi.
Yes, it's a upper triangular. You have to make sure that you get an upper triangular. A last number, it doesn't matter this one. This last number, it doesn't matter. It can be any number, this one. But at the end, you have to multiply. If you got those 1, 2, 3, 4, 5, 6, if you have got 6 zeros, you can now multiply. I'll find. If you have those zeros, those ones, you see, those zeros forms a triangle, which is below the diagonal matrix. Did you see that?
Yeah.
Yeah, if you've got those zeros when you are solving, it means now you can multiply the diagonal. Can we proceed?
Yes.
Okay. So now, let's go to this question. They say find the adjoint. Find the adjoint. It was 2.5 on the question paper that I sent you. They say find the adjoint. This is the question that doing. No, I didn't upload it. Sorry for that, but I copied it. They say find the adjoint. So in order to find the adjoint, you must first find the cofactor. Do you know how to find the cofactor, right? This matrix here, over here, this matrix here is we can represent it like this so that it can be easy for us to find the adjoint matrix. Remember this 1, 1 represent row and column. So I will find. Remember 1, 1 represent row and column. So I will start together. So in matrix here, when we say this is plus, this is minus, 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 this is plus. So when we say how do we find those signs, that's called the an important part. You're going to say row minus column. So on the first row, first column, our first row is 1 minus 1, which is 0. 0, we don't know whether is 0, 0 never be negative. So that's why here is positive. So 1 minus 2 is negative. here. So 1 minus 3. Sorry, I think, let me check. Oh, 1 minus, we're going to say column minus row minus column. So we get what? We get an even. Okay. Add those two. Even number is positive, odd number is negative. Our 5. So when you add those two, 1 plus 1 is 2, which is even. And we know that, yeah, I think you could use this type because that one won't work for subtracting the rows and column. So when you add the first row and first column, you get the even number, which is 2. It means even is positive. When you say 1 plus 3, you got what? Odd. And our odd is negative. So when you say 1 plus 3, you get 4, and 4 is even. Even, we know that even is positive. And when you say 2 plus 3, you get what? Odd. And we know that our odd is what? It's negative. 2 plus 2, 4, even is positive. And you proceed the way it is. So are you fine now with those signs that I wrote here? Are you familiar? Because we are going to use this sign at the end. Are you familiar with that? Hello?
Yes.
Okay. So now, thanks for your response. So now, we're going to find A11. In A11, remember, we're going to draw a line like this. This is A11. Then we write what is left inside here on a matrix. Then we find the determinant. Remember to find the determinant. Determinant is equals to the product of a diagonal minus the product of a non-diagonal. Then the determinant of A11 is 24. So when we are going to find the determinant, we're going to find A22 now. So let's go and find the A22. So on A22, that's where we're going to change this line only, this one, the one that you can see. We only shift the vertical line, we don't shift the horizontal. It means now our vertical line is going to be here. Then that's why A22 now we copy. We are left with what? -3 and 6. -1 and 3. We write those numbers on a determinant form, on the absolute value form. So we find the determinant. So what do you think it will be? A13. Anyone want to try A13?
Master,
Hello.
I think of exercise needs the sign is a plus minus plus minus plus what?
Okay, even is plus. When you add the row and the column, do you get even number here or you got an odd number? 1 plus 1.
Oh, it's true.
Which
It's
is
an
1?
even number.
Then is plus.
Oh.
So 1 plus 2 is 3, which is odd. And odd goes with what? Negative. Did you get that?
Yes, I got it.
Yeah, now, what will be A13? What are we going to do?
Negative.
We're going to move, right? We're going to move this guy here. It means what? It means our A it means our A13 is going to be what? Equals to this guy. -3, 4, -1, -2, right? So are we fine with that? Guys,
Yes.
fine with that? Okay, thank you. So now let's proceed. It means that we have got this guy. This is what we said is going to be equals to width. Then we find the determinant. And now we are going to move and find the A21. So in A21 now, it means we first move the horizontal because we are going to A21. Let me try to erase this. So when we are going to A21 now, we're going to move this horizontal here. And here we are. So now it means we have got 0, 2, -2, and what? And 3. So what to next? The next part is just that we move the what? We move the vertical to find the A22, and we move the vertical again to find the A32. Are you fine with that? Yeah, that's why now here on A21 we're going to have this, and you find the determinant. You find the determinant, and on A22, remember you are going to move your horizontal like this. This is on 2. You are going to copy the number which is here, and here, and here, and here, to find A22. To find the A23, you are going to now to move your vertical line. So it will be like this. You copy the number which is here and here. You copy another which is here and here. You place them inside the determinant form, and you find the determinant. So are you satisfied?
Yes.
Can I proceed? Can we proceed?
Yes.
So now we do the same to A31 now. We go to A31. In A31, you are going to draw a horizontal now on your A31. It will be like this. It will be like this. Therefore, you copy the numbers which is here and here and here and here. Are we fine? Are we fine?
Yes.
Then the vertical only. No, wait, this is a mistake. We don't copy the numbers that are on this one. Which one is it a mistake rather? Is this one? No, it's this one. It's this one. It's the mistake. Even this one. Even this one. You'll get confused if you do that. So you're going to draw a line like this. So you're going to copy those numbers. Yeah, now is correct. So do you understand, or I must go back to the matrix?
between the lines. Now if I'm between the lines, now the left side, please.
This line is at the bottom because we're dealing with the A3. I will find. Check there where this is 0246. Are you fine now? So we are going to A32. We're going to have this horizontal and we'll move our vertical like this. It means there's a this, there's a this, and this value and this value now. It means we are going to obtain this thing. So I will find. Then you find the determinant, find the determinant. So on A33, we have this horizontal, which will remain like that. It means the vertical will move to the last part now. We're going to copy this number and that one, and this number and that one. I will find now.
Yes.
So we're going to rewrite those determinants where they say A11. We're going to substitute with its determinant here, like this. Where they say A11, we substitute its determinant. Where they say A12, we put determinant. A13 determinant. A21 determinant. A22 determinant. A23. Therefore, you tell me what you have. You have what? You got what, guys? Substitute the determinant. I need the answers. Oh, on A11, what did you got on the determinant? You got 24, right? You got this value. Isn't it?
Yeah.
So where they say A11, you place that value. What do you have? Write a new matrix and substitute those determinants here. Then you tell me the final answer. What do you have? You must have something like this. Do you have something like this? Do you have something like this? Guys, please respond. Do you have those numbers? Don't check the sign, just check the numbers. I will tell you what happens to the sign. It means now you have learned something new with for cofactor. How do we find the cofactor also?
Yes, I got the same numbers.
You got the same numbers, né? Now you go back to that table of a sign. You go back to that table of a sign, which is this one. You go back to the table of the sign. So it means the determinant of the sign of a determinant of A11, you're going to multiply it with the positive, and you got what? Positive, right?
Yes.
The sign of a A12, you're going to multiply it with the negative, and you got what? Positive. That's what you have to do, and you must apply. You must multiply others with their sign, with their corresponding sign. That's how you find the cofactor of a matrix. So I will find.
Yes. Yes.
So now, after getting the cofactor, remember we are not asked to find the cofactor. What are we asked to find is the adjoint of that matrix. So now you do the transpose matrix of this. So you are going to find this guy, the transpose of this. What will be the transpose of this? I know you are now fine with the sign. Or like, why did we write a -6, +5, or +3? Hello?
Yes.
You are fine. Eh? So tell me, what will be the transpose matrix of this cofactor of a matrix D? So when the question says find the cofactor, this is what you do. You find the determinant of every element. Then after you multiply the sign that you got for the determinant with the one that you have for even and odd. That's how you find the cofactor. So now, what will be the transpose matrix of this matrix? Okay, guys, how do we find the transpose matrix? Remember, we swap the number of row and column. We swap row and column. So now it means we're going to have this. Are you fine? Is there anyone who have got a question? Remember, we change this row and we write it as a column. Here it is. Are we fine?
Yes.
Are we fine? So you also do the same to this one. You also do the same to that one. So any question before we proceed? Guys, do you have a question so far? And this transpose matrix is our adjoint matrix. Any question? Any question? No question.
Yes, no question.
Okay, so you must be familiar with the properties of the determinant, right? You must be familiar with the properties of determinant. For row reduction, we need properties of the determinant before the method. If A matrix has a row of zeros, then the determinant of A is 0. E.g., let's say we've got a matrix 1, 2, 0, 0, then its determinant is 0 minus 0, which makes us to give us 0. But if we have a matrix that has got the equal rows, then its determinant also is 0. So let's say, e.g., we've got 1, 2, 1, 2. So then its determinant is going to be 2 minus 2, which gives us 0. So for another matrix, let's say we've got a properties row, then let's say we've got a 1, 2, 2, 4. Those, then you got what? Its determinant is 0 also. If matrix A is a upper triangular lower matrix, that's what we were using now to solve that. So this one, if here under we've got the zeros, if you can see here, this is 0. It's a lower, it's a upper triangular. Then to find 0 below the, if we've got the zeros below the main diagonal, it means that this is an upper triangular matrix. Then its determinant, we multiply the what? The main diagonal. That's what we have used to the previous question, to this question. To this question, if you can check, we have multiplied the what? The main diagonals. So are we fine with that? So now let's take an example. Even on the upper, if you've got the lower triangle, it means to find the determinant, you multiply those. You multiply this. Sorry about that, the laptop. You must multiply this. You see, here you must multiply this because the zeros that are under the main diagonals, the element that are under the main diagonals are 0. So now, an identity matrix, its determinant is always 1. If a square matrix and A transpose is a transpose, so it means that the determinant are equal. If A is the transpose matrix of A transpose, then you will find this. So any question before we proceed? This is the example to prove that is there any question? Epio? A transpose. A transpose. Okay, I said that, okay, let's say we have got a matrix A, which is 1, 2, 3, and negative 5. So to find the transpose of A, we swap the row and make it to the column. That's where you get what? You get this. So those determinant of those two are equal. Here it is. If you find the determinant, you're going to get negative 1, negative 11. Did you understand?
Yes.
Yeah, then this is the end of our lesson. So a person who is recording the meeting, please go and save the meeting so that the video won't get lost. Just stop recording and save the meeting. Hello.
RF evaluate the determinant by cofactor expansion. Kuita zvizvila kuita zvone
Cofactor nechipedza na multiply ngadzisign idzila. When you are done, multiply by the sign. Rosita Gamatum Fasity. Here we are. You multiply by the signs. So are you settled?
Okay. Yeah.
Okay. So any question before we end the meeting? Mtu record the meeting not to stop a meeting. No, natural there. Didn't you ever record the meeting?
If we know this distance from there, then we know
Mtu record the meeting can stop a meeting.